Alright, we're going to take a look at a little bit more circles, finding arc lengths in areas of sectors. We were taking a look at degree measures a while back, so now we're just going to kind of extend it out a little bit. But I want you to make sure that you have down there what's in that box. Have the picture and the formula. So I'll give you a few moments to get that to you. A lot of the time when we get these formulas, it seems extremely complicated. What goes where? How do I know what is what? Now again, we've got variables. We just fill in the numbers. We know what 2 is. We know that pi is 3.14. We just use that. Measure of the angle. That is going to be what's out here. Okay. How far around the circle is it? Divided by 360. But that is really the only thing that we're taking a look at here. If you look at this formula, it's 2 pi r. It's basically the same as going around the circle, the circumference. 2 pi r, pi times diameter. And the degree measure that we are given is simply a fraction of going all the way around the circle. So, if I want to find the arc length of W, or say X to Y, arc length, I've got 2 pi, well, that would just simply be 3.14 multiplied by the radius. What's the radius? This is 15. And then, how much of this is it? 60 degrees out of 360. So once we get it there, we can just use the calculator to go through and figure it out so you don't have to worry about messing up on the calculations. So, 2 multiplied by 3.14 multiplied by 15 multiplied by 60 divided by 360. So, that means the length of this here is going to be 15.7. Now, if you read the instructions, it says give your answer in terms of pi. So, if I have to do that, that means what I want to do is not put in the 3.14. So that means I would take the 2, I would multiply by 15, multiply by 60, divide by 360. And that's what we end up with. So how that would look is 2 times 15 times 60 divided by 360, and I end up with 5. So that answer we'll look at is 5 pi. So depending upon what they expect out of you. But then again, you've got to write all this stuff out. You just don't be putting numbers in. You have to make sure that you're writing it out. So, let's try this one. Find the length of an arc with a measure of 75 degrees in a circle with a radius of 4 feet. Okay. Always draw this stuff out. It will only help you. So I got that. 75 degrees would probably be an angle something like that. Right? Ballpark? So, what's the radius? Radius is 4. Okay? So, I need to go and set this up again. Does it say that we are supposed to keep this in terms of pi? The answer is no. So that means I can take 2, multiply it by 3.14, multiply it by the radius, which is 4, then the fraction is going to be 75 over 360. If you have the picture, Makes life so much easier for when it comes to just plugging in the values. What's R? R is the radius. M comes from over here, our degree measure that we're given. So, 2 times 3.14 times 4 times 75 divided by 360, and I end up with 5.23 feet. Does that seem reasonable? Now, next one, area of a sector. Maybe a few moments to make sure that you put this one down so that you have it. All right. Hopefully you recognize this as area of a circle. Area is equal to pi r squared. The only thing that we go and add in extra now is this fraction of degrees over 360. It identifies the portion that we're looking for. So when we don't want all of the circle, it's just a fraction over what we've got. So let's try this. So we're supposed to give our answers in give the answer in terms of pi. Area is equal to pi r squared over 360 degrees. So fill in the blanks. Area is equal to, we got pi. What's r? R is 12, so we have 12 squared. Multiplied by, what arc measure do we have here? 95 degrees. So we'll put 95 over 360. So area is going to be equal to, now mind you, we got to keep this in terms of pi. Just leave pi out there. So you get 12 squared. Multiplied by 95 divided by 360. So we get 30. So, yep, you're right, 38. So we've got 38 pi. Areas, that got to be inches squared, so we put it inches squared. Again, nothing all that difficult. It is just simply going and plugging in the information where it belongs. Okay, we've got another one here. Find the area of a sector with an arc that measures 174 degrees in a circle with a radius of 13 meters. So, I've got my circle. One of the things that I recommend that you do whenever you are working with this, draw this line in here with the radius. When we're working with circles, especially when we move up to trigonometry and we move up to higher levels of math, we deal with this idea of this being at 0 degrees. So if you draw your radius in here, and from there ballpark where your angle should be at, you've got it. A little bit easier to work with. So 174 degrees, where should that be? How far is it halfway around the circle? Almost. Okay. 180 degrees goes around the circle, right? 174 is almost half, so I could probably be looking at a lot like this. Is that reasonable for you? So we got 174 degrees. So, here we go. Area is equal to pi. Does it tell us to go and keep in terms of pi? No. So I am going to take 3.14, multiply it by the radius. Radius is 13, so that'll be 13 squared. 174 over 360. So 3.14 multiplied by 13 squared multiplied by 174 divided by 360. Area is equal to 256.5 meters squared. Always like it a lot easier when it's just formulas and calculations. Plug it in. Okay. Now, one of the other uses for formulas is just because it's a formula for solving for area doesn't mean that that's all you have to use it for. I want to find the radius of this circle. The information I'm given is that area is equal to 100 meters squared and 256. I don't know what the radius is going to be. So, area is equal to pi r squared multiplied by our measure over 360 degrees. Part of the reason why I want you to have the formula on your little book is so that you don't have to worry about remembering it right away. You got it, you can look at it, okay, I can translate. Area, well, that would be 100, correct? They told us that A, so we'll put it in, pi, 3.14. Radius, do I know what that is? No, so that's going to be r squared multiplied by 246 over 360. Now, it really doesn't matter how you want to do this. The algebra and math, I can take the reciprocal of this, multiply it over there, divide by 3.14. I can take 100, have my r squared here, and just get a number here. It really won't matter how you want to do it. But if I go and take 3.14, multiply it by 246 divided by 360, I end up with 22.1600, so we'll go 62. Okay? Does that make sense to you to do? Yes or no? Make sense? Sure. What's the error? Yeah, no. It says 33.1. Is that something I have to work with? No. It was supposed to be what? When you're dealing with the calculator, always make sure that you are looking at the work and writing things down. Part of the problem is you get used to hitting buttons and coming up with answers. You don't bother paying attention to it. When I did this, I typed in it. My calculator went to 33.1. It did not do 3.14, did it? So try that again. 3.14 multiplied by 246 divided by 360. Does that look better? So when you're going through, you got to have kind of a ballpark idea of whether the numbers look right. I mean, 22.62 seemed a little on the large size. So, erase this out of here. And we end up with 2.15. Okay. Now, divide both sides by 2.15. Divide by 2.15. So I have 100 divided divided by 2.15. So I end up with 46.51 is equal to r squared. Now I have to take the square root of that, right? Square root of 46.51162791. So radius appears to be equal to, let's see, 6.82. Now this was in meters, so it's going to be in meters. Don't just go and try and slam a bunch of stuff into a calculator. If you take this step by step, identify the formula, put in the numbers, then do the calculations, be helpful. Can I solve for an unknown central angle? Sure I can. What information have I been given? Well, it says the length of the arc is 12 centimeters, so that means that this is 12 centimeters up here, going around from here to here. So that means I am going to have to use the other formula. So that's going to be 12 is going to be equal to 2 pi 3.14 multiplied by the radius, which is 14, multiplied by the arc length, which is what we're looking for, that's the m, divided by 360 degrees. So, well, this seems easy enough, right? I can take 12, set it equal to, I can take 2, multiply it by 3.14, multiply it by 14, and then divide it by 360. So I end up with, yep, see that there? 2 times 3.4 times, why do I have a plus on there? Divided by 360. Now, is that better? So I get 0.2442 m, whatever that is. So, divide both sides by 0.2442, divide by 0.2442. So 12 divided by 0.2442, and I end up with 49.14 degrees. But big catch is you have to write it out, you have to work it out so that you can see what your work is. So, spray irrigation system has a radius of 150 feet, rotates through a 175-degree central angle. What is the area that the system covers? Round your answer to the nearest square foot. Actually, it would be more appropriate to have this thing rounded to the nearest acre, but we'll go from there. So we want area. Area is equal to pi r squared multiplied by the measure of the angle over 360. So plug in the information that we have. Area is equal to pi, okay, 3.14 because it wants it to the nearest square foot. Radius, 150 feet. How do I know that? Well, if you got a spray irrigation rig, sits here, the boom goes out this way, right? And we'll make an arc as it goes. That's 150. If you don't know what the picture is going to look like, ask, draw it out. One of those two ways is going to get you to what you need. So we know that the angle measure here is going to be 175 degrees. Okay. And that's going all the way from here over to here, back and forth. That's what we're looking for. So, got 150. So that's going to be 175 over 360. Do I have all the information in there? So, area is equal to 3.14 multiplied by 0 multiplied by 175 divided by 360. And that should be good. So we get 228.96 feet squared. By the way, you know how many square feet are in an acre? Sorry, sir, no. A section is 1 mile by 1 mile. A section is 640 acres. So, if I go and take 5,280 feet, because that's the distance of a mile, correct? 5280 multiplied by 5280. That means that there are that many square feet within 640 acres. Okay? So if I divide this by 640, that will tell me, whoops, that was 650, excuse me. Divide by 640. That means that within an acre, there are 43,568 square feet in 1 acre. Did I? No. Did I square that? Did I miss something? Now, if I don't have my calculator out, I'm just sitting here punching in a bunch of numbers. I don't look at the screen. I don't look at what I have written down. Would I even begin to notice this? No. You keep wondering why in the world I harp on you guys to show your work. This is one of the reasons why. You forget to write something down, or you're trying to get through it too quickly. This is what happens to it. Now, I am going to keep this number here real handy, so I've got 43561 number of square feet an acre. Because I was trying to get down to this point here that, well, gee, if I only have 228 point that feet, something doesn't seem right here, does it? I mean, for those of you that understand what an acre looks like, and an acre really isn't all that big, is it? That number of square feet sounds good. I mean, I'm not even at a small fraction of an acre. So something had to be wrong. This is why we check our work. This is why we write it out. This is why we learn how to estimate things and say, well, that seems right. So, back here, that's got to be squared, correct? Let's do it all over again. 3.14 multiplied by 150 squared multiplied by 175 divided by 360, and I end up with 34,343.75. Okay. Now, that seems to make a little bit more sense. Feet squared. I mean, if you think about it, 200 feet squared isn't even the size of this room. Okay? So you got to be kind of careful about it, understand what things should look like. So that means that if I go and take this and divide it by 43560, I either get too many or too few. There it goes. That means that I've got probably roughly 1 acre. Yes, sir. I messed up. Yes. Where'd I? Well, I got the other calculation right. I'm just wondering, my calculator keeps skipping on me. I don't know what the problem is with it. So 5280 squared. Divide that by 640. So 1 acre. So I got that number right, 43,560, and I got 34 that. So that means that I'm probably at 150 feet. I am looking at 3/4 of an acre. That actually sounds a lot more reasonable. Okay. So I'm going to give you a few minutes here, and I want you to go through and work this problem out. Okay. So the first thing that you should do on the paper before you do anything else, draw up the situation. So on your homework, I'm going to expect to see a circle. If I don't see a circle, you haven't done the problem yet, have you? Please make sure that you write it out. Draw it out. So I'm going to start here, go over here, and I have a radius of 12. Okay. Find the length of an arc with a measure 125 degrees. Where's 125 degrees? Well, we know 90 is up here. We know 180 is over here, so it's probably going to be sitting in here someplace. So that's 125 degrees. Now, it wants us to find the length of an arc. So that is going to be, let's see, distance here is going to be equal to 2. What's pi? 3.14. Radius, 12, multiplied by 125 over 360. Again, don't try and slam it into the calculator without writing it down for the equation. I mean, if you've got this down here, then you've got to work out the equation. Great. You at least have a backup to see where it went wrong if it went wrong. So I got 2 times 3.14, multiply that by 12, multiply that by 125, divide that by 360, and I end up with, my arc length is going to be 26 point, down to the nearest hundredth, 0.17. And we are in miles, so easy enough. Give you time to do this one. All right, here we go. Area. Pi, 3.14. Radius, 7.5 squared. 35 over 360. Clear it out. 3.14 times 7.5 squared, multiplied by 35, divided by 360. And I end up with my area being equal to 17 point, nearest hundredth, so again, 1.7 inches squared. Make sense?